Hello and thank you for your interest. My name is Constantijn Kalant and I will present to you the latest findings on word stress in Papuan Malay. The talk is titled Papuan Malay Word Stress Reduces Lexical Alternatives and it is joint work with Vincent van Heuven. So many studies have shown that word stress can play a facilitating role for word recognition. For example, it could speed up word recognition by helping to reduce the number of alternative word candidates available for the listener. The extent to which word stress has this facilitating effect differs per language. As we will see in this presentation, even closely related languages could differ extensively. For example, much depends on what acoustic cues are used to signal word stress and the extent to which these cues are either suprasegmental, like duration, intensity or spectral tilt, or segmental, such as vowel quality. So the study I present to you here focuses on a specific language spoken in eastern Indonesia, Papuan Malay. Much more research needs to be done on this language, and some existing work provides different views on the role of stress. It has been claimed, for example, that this language, like related languages, does not have word stress, although recent work did find some consistent acoustic support for word stress claims made in a grammar. The claim is that this language has regular penultimate stress in around 90% of the cases and in a small number of exceptions has ultimate stress. This rather asymmetrical distribution can be taken as an indication that if this language indeed has word stress, its functional load is probably limited. The controversy concerning word stress in Papuan Malay relates to a larger debate in the literature about the existence of word stress in Indonesian languages. It goes beyond the scope of this presentation to discuss this issue in much detail, but some lessons can be learned. For example, it is crucial to take into account regional differences. The linguistic diversity in Indonesia is large and challenges work that has attempted to generalize over language families. Concerning stress, for example, it has been shown in perception experiments that listeners of the Javanese variety accept acoustic cues to stress at virtually any syllable, whereas listeners of the Toba Batak variety show a clear preference for penultimate stress. Unlike the perception study I just mentioned, the stress controversy is partially driven by the scarcity of empirical work. More than often, underdocumented languages are described only in grammars, with little to no attention to prosody, and if so, no empirical data to support the impressionistic claims. On a more general level, the stress debate relates to our definition of word stress. Languages of the world differ extensively in how stress is manifested, and accordingly, studies differ in how they quantify stress, with some acoustic cues being structurally overlooked. To start simple, stress is generally defined as a single, most prominent syllable in a word. Its prominence is acoustically signaled by duration, vowel quality, some form of intensity, sometimes spectrally weighed, sometimes overall intensity, and F0. Research has shown that when it comes to the acoustic cues to word stress, there is a crucial difference between speech production and speech perception. This can be illustrated when considering the available work on English and Dutch, two closely related languages that appear to differ substantially in their use of word stress cues. English and Dutch show a lot of similarity in the rhythmic aspects of prosody, and when looking at production, both languages use similar cues to stress in their speech signal. However, perception studies have shown that duration is the most prominent acoustic cue to stress perception in Dutch, whereas vowel quality is the most important cue to stress in English. Now we turn to one of the functions that word stress may have in a particular language. One such function is to reduce the number of alternative word candidates. This is done by bringing down the number of similar sounding words. A number of studies have investigated this function in lexical analyses. They started using a word database, which was based on corpus data, which were then meant to reflect the mental lexicon, including frequency data. The main analysis on this data concerned a count of embedded words. So one starts by counting all words that have a word embedded in them. For example, the English word beanie has the word bee in it. Then all embeddings were counted, so bee is embedded not only in beanie but also in belay. Finally, the number of embedded words were counted when stress information was taken into account. So in that case, B is embedded only in beanie and not in belay, because B has one syllable and it is therefore stressed, matching with the stressed syllable in beanie, but not with the stressed syllable in belay. Now, to get an idea of the functionality of word stress in a language, the total number of embeddings should be compared to the number of embeddings left after taking this stress information into account. So the latter number is likely to be lower than the former, and larger differences can be taken as an indication for higher degrees of stress functionality. So this type of lexical analysis have been done for at least 4 languages. So when we combine their data into one table, we can compare the extent to which stress can help to disambiguate words in these languages. So we can see that the mean number of embeddings found in a word is around 1.5 for Dutch and German, and 2, almost 2.5 for Spanish. English, on the other hand, has less than 1 embedding per word on average. When we look at these numbers after taking into account stress information as a disambiguating cue, the number of embedded words in all languages drops below 1. The proportion of stress-matched embeddings left is therefore reduced to 1/3 in Spanish, to 1/2 in Dutch and German, and to 2/3 in English. The comparison thus shows that Spanish heavily relies on stress cues to reduce the number of alternative word candidates. The case of English deserves a little more discussion, because it is the only language here that does generally not rely on word stress cues at all. This can be seen from the low mean number of embeddings when all embeddings are counted. This number is below 1, indicating that more often than in other languages, English words do not have embeddings in them. So there's less need to disambiguate in the first place in English. This conclusion is in line with work that showed the importance of vowel quality in English. In most cases, stress is not cued suprasegmentally, but rather segmentally, which predicts indeed a low overall number of embeddings. So now we turn to Papuan Malay. So we see the region here where this language is spoken. So Papuan Malay belongs to the Eastern Indonesian Trade Malay family, spoken in the provinces Papua and West Papua. Other members of the family are Manado, Moluccan, Ambonese, Banda, Larantuka, and Kupang. Although all these varieties belong to the same family and show similarities, there are also important differences to be expected, in particular given the large distances between the areas where they are spoken. Stress research on Trade Malay languages reported contradicting findings. For Ambonese, initial stress claims were rejected by an acoustic analysis. In that way, the initial claimed minimal stress patterns turned out to be segmentally different. Manado Malay was reported to have penultimate word stress, although no acoustic or perceptual verification for this claim has been carried out. So for Papuan Malay, a perception study on phrase prominences and boundaries concluded that this language lacks word stress. An acoustic analysis, however, at the word level showed that duration, spectral tilt, and vowel reduction are the strongest correlates of word stress, in accordance with the claims found in the most recent grammar of this language. Furthermore, the only 2 mid-vowels in Papuan Malay, e and o, tend to reject the otherwise regular penultimate stress pattern consistently, indicating the importance of vowel quality and word stress placement in Papuan Malay. So, given the existing lexical research on the functionality of word stress and the limited inconclusive research on word stress in Papuan Malay, this study aims to answer the question, to what extent does Papuan Malay stress facilitate word disambiguation? We investigated this question with a lexical analysis, which resembles as close as possible the ones that were already carried out for Dutch, English, German, and Spanish. In this way, we can shed light on the degree of disambiguation that can be ascribed to word stress cues in word recognition. If word stress indeed reduces the number of alternative word candidates, we should observe this in the lexical statistics. And in a larger context, this analysis aims to shed light on the role of word stress in Indonesian languages, which to date remains somewhat unclear. The lexical analysis we carried out concerns 1106 Papuan Malay words taken from the word lists available in the grammar by Kluge. The selected words are a subset based on the exclusion of loanwords. There are quite some loanwords in Papuan Malay due to the language contact in the distant and more recent past. We furthermore included only single instances of homonyms to avoid counting too many embeddings. And we also excluded 4-syllable words as they appeared to be very few. So one limitation of our approach is the lack of frequency data. It's important to point out, frequency data was used in previous lexical analysis to weigh the number of embeddings. There is no corpus available for Papuan Malay on the basis of which we can compute word frequency. So it has to be noted though that the collected words by Kluge all came from informal conversations where everyday topics were discussed. So we therefore assume that the word lists provide a representative subset of the Papuan Malay vocabulary in terms of frequency. So the table here provides the overall counts of mono, bi and trisyllabic words with either penultimate or ultimate stress in the word list. It can be readily observed that penultimate stress is the most dominant pattern. So now we turn to the results of the counting of the embedded words. Just to make the counting clear once more, so we ensured that the embeddings matched for syllable boundaries. So a word like ke was counted as embedding in keva, but not in kembang. The table shows the number of embeddings for each word length. As you can see, the single syllable words were part of the list, but they are too short to count as carrier words for embeddings. So the column on the left shows the total number of words with embeddings. The middle column shows the actual number of embeddings. So some words might indeed have more than one embedding. And the right column shows the number of embeddings left when stress is taken into account as a disambiguating factor. Now that we have seen the overall results, we can further split them according to where in the carrier word the embedding starts, which could be the first, second or third syllable. This information gives us an idea of where in the word stress information plays a potential disambiguating role. So, the top table shows the counts for all embeddings, indicating that most embeddings, 95, were found in the first syllable of bisyllabic words, and almost half of that amount was found in the second syllable. For trisyllabic words, which are less frequent than bisyllabic words, embeddings started equally often in the first and second syllable, and a small number started in the third syllable. So after taking stress into account, the number of embeddings reduced for almost all cases. A particularly large decrease can be observed for bisyllabic words, where the embedding starts with the second syllable. So it's a decrease from 44 to 5. For trisyllabic words, the largest decrease, so no embeddings left at all, can be observed for embeddings starting in the first syllable. These results show that embeddings were mostly reduced when the embedding matched an unstressed syllable in the carrier word. So this result can be explained by recalling that stress is mostly penultimate, so the embeddings themselves tend to start with a stressed syllable, either because they are monosyllabic or because they are disyllabic. Now that we have the Papuan Malay numbers, we can compare the mean values to the ones we already took from existing studies. Now we see that the mean number of all embeddings per carrier word is just above 1 for Papuan Malay and reduced to 0.64 when stress is taken into account, making the ratio of unambiguated words left 60%. We can now conclude, therefore, that Papuan Malay stress patterns contribute to reducing the number of alternative word candidates and that word stress therefore has a function. When looking at other languages, we can observe, however, that the disambiguating function in Papuan Malay is small. Languages such as Dutch, German and particularly Spanish rely more heavily on word stress for disambiguation. So Papuan Malay seems rather similar to English. The similarity mainly holds when considering the ratio of embeddings not being disambiguated by stress. For both English and Papuan Malay, this ratio lies around 60%, indicating that the largest part of the disambiguation is done by segments. In English, we know that vowel quality is the most important cue to stress, which might also hold for Papuan Malay. This would support at least the outcomes of previous work showing that mid-vowels are crucial for stress placement in this language. It is important to also look at the mean value for all embeddings. English has a number below 1, indicating little a priori need for disambiguation by stress, whereas Papuan Malay has a number just above 1, suggesting the intrinsic need for stress disambiguation. This is remarkable because English is traditionally analyzed as a stress language, without controversy. This could therefore be taken as an indication that stress in Papuan Malay should be taken as a reality, and a useful cue to word recognition. It is important to stress once more that the frequency data was lacking in the study and that the numbers might turn out to be different when applying the same approach to a larger corpus. I thank you for your attention and please contact me for further questions or comments.